Hi, this is Team Forecasting Success from Challenge 12A.
MAC is an engineering consultancy in the construction industry. There have been over 2,500 inquiry records collected over the last few years in one of the teams within the company. During the bid process, to predict the outcome of the bids is always guesswork, relying on gut feeling rather than a more scientific approach. The challenge the company is facing is that can the company have a better understanding of what work it is likely to win so that it can be better organized?
Now, we are going to present you the overall process that has been followed. First, we needed to check the quality of our original dataset, where we identified some issues such as poor quality of the data prior to 2017 and some missing values from our key data fields. This brought us to our next step, which has to do with the cleaning of the data. During this process, we created two datasets. The first one included the key data fields, but due to missing values, we only had 1,416 records. The second one had more records, but it did not include the key data fields that were missing values. Afterwards, we started to develop our machine learning classification models. After pre-processing our data within the Google Colab environment, in order to achieve the right format of our data frame, we decided to try three different classification models for each dataset: logistic regression, random forest, and neural networks. From these models, we picked the most accurate one, and based on this, we created a Python notebook to forecast the success of future bids for new datasets, which we export to Excel files. Finally, for the visualization part, we used Power BI to analyze the existing datasets based on key fields and compare the accuracy of our machine learning model.
In addition to the machine learning modelling, we have also provided an analysis tool within Power BI which looks at inquiries that have a won or lost decision. The tool allows you to analyse by time periods, work type, client, office and fee writer.
This slide gives a quick idea of the nature of raw data and the data we prepared from it. Based on the assessment of the raw data, we cleaned it up and prepared two datasets. Dataset 1 is the dataset with date fields. It has lesser records because we removed the records with data entry errors on date fields. Whereas dataset 2 is the dataset without date fields. Since we removed the date fields, we could accommodate more records in this dataset. Based on this, we have tried to use both the datasets to evaluate our machine learning models.
Onto the model development slide, you can see that we trained three classifiers: a logistic regression, a random forest, and a neural networks on two versions of a dataset, one with date information and one without date information. And in the next slide, you can see the results shown with Power BI, and you can notice that the accuracy was always higher in the dataset with dates for all three models. However, the recall for the loss values was much lower for logistic regression and not much higher for random forest. We decided that the artificial neural network was the most promising based on accuracy, based on recall, and based on precision as well. And you can compare the values. On to the next slide, you can see that for the prediction result, we got 86% accuracy in the train set and 82% in the test set for the dates data set with the sequential neural network. The imbalanced data meant the precision recall for the latter, so for the losses were worse. And we also want to take care that categorical values like companies and fee writers are kept up to date, and we need to retrain the model every now and then if it's changed.
We have identified three main benefits, one being forecast workload. So future work can be analysed using the model to predict which products are more likely to be won. The second is Power BI analysis. We've provided analysis on existing data, but also the capability on the predictions. The third is the adaptable model. The model can be easily adapted to be used on different datasets as well.
Further developments. The first further development we have identified is to expand the data set by including more data fields. The model we have created can easily be modified to include more. The impact of this would be improved accuracy to the machine learning model. The second further development identified would be to create a model to identify the key data fields of the model. The impact of this would help understand which of the data fields have the biggest impact on the model. This would help the business prioritize actions on key elements. The third further development identified would be to further develop the model when more inquiry records become available. This would further improve the accuracy of the machine learning model.
For the key predictive factors of our model, we were able to detect that they were the value of the bid, the days since received, and the days since issued. We did face a lot of problems with regards to data quality and data volumes, and when we proceeded to clean the data, that meant we had to cut out around 40% of the data to improve the accuracy of the model. For the third question, for data provided for 2020, it often included empty dates. Therefore, the team decided to remove that data from the model. However, the model does not account for any outlier factors or any external factors.